In this section, we're going to define what is a function and we're going to talk about the domain and range of a function. So, we need a formal definition. What is the difference between a relationship between x and y and a function relationship between x and y? So a relation just says this y goes with this y goes with this x. With it can be any conglomeration of x's and y's. A function is one that specifically assigns a single value in the range to each value in the domain. We'll talk about those two words in a little bit, but a better way to think about this, a way that may help us understand this in a slightly different way, is that in terms of like x is the domain and y is the range, we would say that if f is a function, or we would say a function is a relation where every x has one right answer y that goes with it. Think about it. Do we like it when there's one right answer or like three right answers? What is an easier math problem to deal with? Well, it's nice when everything has one right answer, right? So when I plug in an x and only one answer comes out for y for every single x, that is a function. In other words, if you have an x and it has two right answers or three right answers, then that cannot be a function. So what is a function? A function is when I plug in an x, every single time, one right answer comes out. That's it, right? So let's look at this from a mapping perspective. Here's the x. We plugged in p, out came m. We plugged in q, out came n. We plugged in r, out came n. How many answers were coming out for each of these? Just one. Yes, we repeated n. Nobody said we couldn't repeat answers. We just said one right answer. So this one is a function. If we look at this second mapping here, p goes to x, plug in q, out comes y, plug in r, out comes z. Every single one of those has a one right answer y. So this one is also a function. However, if we look at this last one, okay, plug in a p, the answer is x, one right answer. But when I plug in q, how many answers come out? Y and z. Two answers y for one x. This one is not a function. So we need to be able to identify, is it a function or not a function, in various ways. This is our mapping version of is something a function or not. We also need to be able to look at a set of ordered pairs and their x's and the answer y that comes out and determine if something's a function. So if we look at this first example, when x is 1, y is 2. One answer. When x is 3, y is 4. When x is 5, y is 6. When x is -1, y is -3, and so on. And so we can see for every x there is one answer y, and this one is a function. Let's look at this one. At first glance, this guy looks like a function. When x is 2, y is -1. -1 goes to -2, 1 goes to 2, 0 goes to 0, 2 goes to 1, and -2 goes to 1, and 2 goes to 1. It looks like a function, but actually there is an x that has two right answers, and it's these two pairs right here. Because when x is 2, in the first one, y is -1, and in the second one, y is 1, and they're both part of the same relation, which means this one has one x with two y's. This one is not a function. And if you take a moment to look at the rest of these, you'll notice that this one is a function, even though we have the same y value for these. That doesn't matter. Remember, every x has one answer y, so this one is a function. But if we look at this one, when x is 6, y is either 1 or it is 2, so this one is not a function. All right, we're going to jump to the next page for just a second. We'll come back to domain and range. We also need to be able to determine from an equation whether something is a function. And here's kind of the big hint. So if you remember from Unit 1, Let's say that y squared was equal to the number 4. Well, how many answers y will we get out of this? Well, when we square rooted both sides, what did we have to remember to add? Well, we had to remember plus 2 or minus 2. So whenever we have a y squared, there's actually two y's that are happening here. So that's kind of our big hint, is that if you ever see an equation where there is a y squared, this thing probably isn't a function, because there's going to be something that I can plug in for x where we're going to get two y's for that x. So let's look at these first two examples. Y minus 2x equals negative 5. Y is not squared. So every time I plug in a number for x, let's plug in 6. We have negative 12. We'll add that over here, and we get 7. Y is 7. And it's that easy. You got one answer y for that one x. And it doesn't matter how many x's I plug in, that's always going to give me one answer. So this one is a function. If it has a y squared, it's probably not a function. Whereas, let's look at this one. Do you see the y squared? This one isn't a function. And I can prove it to you by plugging in 0 for x. Because when I plug in 0 for x, I get 0 squared plus y squared is 1. And so y squared is 1. And when I take the square root of both sides, what do I get? Plus or minus 1. I get one x of 0 that I plugged in, but two y's that came out. This one is not a function. And it was just, you can use that little shortcut to say it's not a function if there's a y squared. We're just kind of proving it to you. So look at these last two and just very quickly tell me, is it a function or not? Well, y is not squared. X is squared. We don't care if x is squared. We care if y is squared. So this one isn't squared. So it is a function. Over here, y is squared, so this one's not going to work, and so this one is not a function. If you want to prove it, the easiest number to plug in for x is negative 6. All right, our last version, we have to be able to tell if something is a function by looking at its equation, looking at its map, looking at a set of ordered pairs, and by looking at a graph. This one is my favorite one because we end up coming up with a really cool rule. So look at these two graphs right here, and we're going to actually ask ourselves, is this a function or not? So let's look at this one. When x is 0, y is 0. When x is 1, y is 1. And if it was a little bit bigger, when x is 2, y is 4. Here, when x is negative 1, y is 1. And if we went a little further, when x is negative 2, y is 4. And you can see all the way along here, every x has one answer, y. But if we come over and we look at this graph, let's particularly look at when x is 4. This point is on the graph, and it is x is 4, y is 2. This point is also on the graph, and it is when x is 4, y is negative 2. And what do you immediately notice? You notice that I have one x with two different y's. And the way we can quickly then determine that this one is not a function is that when I draw a line between these 2 points, notice it's a vertical line. So if you can draw a vertical line through any 2 points, you know that this thing is not a function. Let's look at, say, this guy right here. Look at this. We have when x is 2, y is negative square root of 2. And when x is 2, y is positive square root of 2. We also have it here. Now, it doesn't have to be that every vertical line has 2 points. If you can do it once, any one time, then this thing is not a function. It's broken that rule. Whereas if we go back, so this one is not a function because we have drawn a vertical line through more than one point. It fails what we call the vertical line test. Whereas over here, every vertical line that I draw only goes through one point. I can't draw a vertical line through 2 points, so this one is a function. So this is called the vertical line test. If you can draw a vertical line through 2 points or more, it is not a function. That is the vertical line test. So let's quickly look at these guys right here and determine function or not. So every vertical line here only goes through 1 point. This one is a function. This one is also a function. But if we look at this guy, look, there's a vertical line. Did it go through 2 points on the graph? Yep, this one is not a function. And my favorite one here, look at this vertical line right here. It goes through 2 points. Again, not a function.